Hey guys, Sam here. So, I've got some news since the last video. First piece of news is that I just decided to put a piece of aluminum foil and use that as my element sample for aluminum. As you can see. Yeah, pretty simple. But I got some bad news, which is that the vials with mineral oil in them, they leaked. So now there's oil stain all over the wood, all over the cork. That's a problem. A lot of it's drained out, but I don't think that's really a problem because the thin coating of oil on the metal pieces, it really helps to block them from oxygen and water too, because oil and water don't mix. If you remember those 4 elements I put under oil, yeah, they made a pretty big mess. I had to put a towel here. No, 2 towels. It's that messy. Not good. I'm gonna have to clean those vials. But anyway, I've decided that I'm going to do the lower middle shelf and the bottom shelf in the same video, because there really isn't a lot to do here. So let's get started. First of all, I got some zirconium. A little cylinder of it. Nice little bronze golden color. I mean, we probably know that like most metals in the periodic table are just silvery or gray in color, but in fact, every element has its own unique color. It's just that it's often very similar, so we don't notice it. Niobium right here. Some little pellets of it. Put a vial in there just to keep the pellets in. And I did the same for molybdenum. These pellets are even smaller. It's almost like a metallic sand in there. It's crazy. Oh yeah, and then I got silver. Now I've actually got a couple of samples for silver. First up, I've got this 1 ounce bullion. It is super shiny. Look at that. That's crazy. And then there's the front. You can see that there's a bit of tarnish around the edges, but it actually looks a bit pretty in my opinion. And then I got a mineral specimen of native silver. There might be some gold in there too. Kind of looks like gold. Could also be maybe some sort of pyrite, but not really sure. A few pieces though, they broke off of that mineral specimen. See? It's really sparkly. And the next up is a really fun element, indium. Indium is an extremely soft metal. In fact, this used to originally be a cast bar of it, but then I just mutilated it for fun. And yeah, I did bite into it. Not a good idea to bite into random things, but it's not a toxic metal. I've seen other people do it too. Anyway, I'm actually going to take this out, because this is kind of an awkward fit. See if I can squish this. Not quite that soft, but I can still bend it pretty easily. It's hard to show that on camera while you're holding the camera in addition. Okay, let's just bring out a hammer. There we go, I just crushed it with a hammer. From the videos I showed of me messing up the bar, you can probably tell how easy that must have been. It was pretty easy. Alright, there we go. Indium. Next up, tin. This is actual pellets of tin. Really pretty looking. But, I mean, there's really not much else here. Let's move on. Iodine. It's a ampule inside an ampule. Well, an ampule inside a vial. But this ampule, unlike the one I had for selenium, this actually turned out to be small enough to fit pretty well inside the vial. That's pretty nice. But it's it's a pretty beautiful element. Really nice crystals. I'll have to be careful not to accidentally break this, because corrosive vapors will get out and ruin a lot of things. Well, I think that wraps up the lower middle shelf. Let's move on to the bottom shelf. Alright, this is the messy part. So these are the 4 elements I got and put under mineral oil. But of course they leaked, so I put towels here. This is terbium. Fun thing about terbium is that it's actually one of the most strongly magnetic elements in the periodic table. So here I've got a powerful magnet. See, it kind of attracts. Terbium is paramagnetic, meaning that it's attracted to a magnet, but it can't be a magnet itself, which is pretty interesting. And then next up, dysprosium. Also paramagnetic. So, more weakly than terbium, though. And then there's holmium. Also paramagnetic, though once again, it's a bit weak in comparison to terbium. And then there's ytterbium. Yeah, it's... people who named these didn't really have a lot of imagination. Terbium, erbium, yttrium, ytterbium. Jeez. Anyway, this is ytterbium. It's really pretty, kind of yellowish dendrites in here. It's really nice. Kind of had to pull them out of the vial because they were just kind of stuck in there. Just kind of had to grab them, pull them out. Okay, so those are the 4 elements. I just revealed them. Oh jeez, my hands are getting kind of oily. Okay, after cleaning up the oil, wiping it off, next up, hafnium. Little pellets. Tantalum. It's kind of a bluish metal. It's really hard and heavy, but at the same time it's pretty malleable, so I can easily take one of these out of the vial and bend one. Let me just demonstrate that. Yeah, see? It's quite hard, but at the same time it's very malleable. Next up I've got tungsten. It's a bit too big to fit in the vials, but I'm not even going to attempt to hammer this to get it to fit, because tungsten, it's one of the strongest and hardest elements in the periodic table. I mean, it's one of the first things that comes to mind when I think about strength. No way am I going to attempt to get the tungsten to fit. That'd be a nightmare. It's just a really nice cylinder. It's pretty heavy, as tungsten should be. Next up's an interesting element. Rhenium. Rhenium is one of the rarest elements, so I'm very lucky to have a sample of it. This tiny little piece is worth quite a lot. It's pretty hard and heavy metal, like the other ones I just showed. It's a bit radioactive because of rhenium-187, but the energy of the beta particles is very, very low, so I couldn't detect anything with a radiation detector. The particles were just too low energy, they were out of range. Next up, bismuth. Very special. I got this crystal here. I'm not really sure if I want to break this up or if I should just leave it like this. You can, like, decide. But it's really nice. You can see there, like, a part of the crystal that's broken, and you can see kind of the brownish color of bismuth when it doesn't have that oxide film. I mean, it does have an oxide film, but unless it's crystal in it, it's too thin to really interact with visible light. So, yeah, that's pretty much my whole collection so far, and in addition I've got a couple more that are coming for Christmas. And Christmas is very soon, so, I really hope to see you guys, then. I'll, have some fun. But anyway, I really hope you enjoyed me going through my collection. I've got some very cool ones in here. In addition, me and Dad, we're going to be working on a periodic table display on the wall over there. That's going to be very fun. I really hope you enjoy that, too. But anyway, that's it for now. Bye.